Okay, so this is a continuation of our notes that we started, gosh, my days are almost up, on Tuesday, notes 9.3, when we did trig functions of any angle. But now we're actually more focused on that value of theta that's happening. What you guys did for me on Tuesday, you didn't need to know theta. You just needed to be able to draw a triangle and find the three sides and label SOHCAHTOA. So a reference angle, I went ahead and put the page number here because we will draw some pictures, but if you want to look at the book definition and pictures again, it's on page 480, so that might be helpful for some of us if we want to look at that textbook. Okay, one really important thing to remember about your final answer for a reference angle, it has to be positive, so don't give me any reference angles that are negative, and it has to be acute. What do you know about acute angles? Between 0 and 90. Okay, so 0, I'm going to say theta prime is less than 90. Okay, so it's in between that. And we could also think about that in radians. It's between 0 and pi halves. We have a new notation that we'll use for reference angle. So it's saying not the original angle, but the reference angle. And we call it theta prime. So you probably remember that notation from geometry, like when you would reflect or transform a point on the coordinate plane. It was like, not the original point A, but the new point A after I reflected over the y-axis. Okay, so it's the same idea. Not that original angle measure, but the new one. And it's formed by two things. Your terminal side, which remember, you got your initial side is on the positive x-axis. And your terminal side is the side that opens up in any of the four quadrants, right? So I'm talking about this arm that's moving around. It's formed by the terminal side and the x-axis. So depending on which quadrant you're in, how you calculate your reference angle is going to be different because you need it to be that positive acute angle. Okay, so that's what we're going to see in our pictures down here. So I'm going to start with quadrant 2. I'm skipping quadrant 1 because what do you know about all the angles in quadrant 1? They're already positive and they're less than 90. I mean, if they were negative or if they were more than 90, you'd have to do a coterminal angle, right? Add or subtract 360, add or subtract 2 pi. But when you finally got to that angle in quadrant 1, that's between 0 and 360, it would already be positive and acute. Okay, so I'm skipping right ahead to quadrant 2. And you could easily draw in your notes, just draw a coordinate plane. I got my initial side on the positive x-axis. I've got my terminal side anywhere in quadrant 2. And I'll just draw like the simplest angle, a positive angle theta without extra rotations. But certainly I could go make a spiral and go around 2 times and then some into quadrant 2. I'm going to keep it simple here. Now, I'm going to use green to draw my reference angle. Where is my reference angle? It's formed with the terminal side of theta. So I'm going to trace the terminal side of theta and the horizontal x-axis. Now, there's 2 sides to the horizontal x-axis, but I have to draw it so that I'll get an acute angle. So I have to be drawing it to the left, the negative x-axis. So this right here, that's my theta prime. Okay, and then what we want to do is we want to think about if we knew what theta was in degrees or in radians, how would we be able to evaluate theta prime? So, you know, in terms of like formulating this, because you got to know this for quizzes and tests, and I would say more than memorizing it, like trying to understand why it is what is this going to be easier for you, I use a number. What if theta was 120? How would I find theta prime? Subtract it from 180. You might look at that just from geometric perspective and say those two are a linear pair. They share a side, they form a line. Okay. Awesome. So let's write that down. theta prime equals 180, but instead of 120, I'm going to say minus theta. And that would work if theta was 95, 110, 150, whatever, right? Now, what would you change about that if I gave you one in radians? So 120 degrees in radians is 2 pi over 3. Jet, what would you write instead of 180 minus theta? Pi minus theta, because it's just a straight substitution for 180, right? We know 180 is equal to pi. So it'd just be pi minus theta. So 2/3 pi is equal to 120 degrees. Well, pi minus 2/3 pi is just 1/3 pi, which that's in quadrant 1. It's positive and it's a cube. Okay, let's do the same thing, but we're going to move our picture. We're going to put it in quadrant 3. Okay, so you can draw your own picture. Okay, quadrant plane, terminal side, quadrant 3. I'll label it Q3. I don't mind if you're labeling quadrants if you use Roman numerals or regular numbers, whatever works best for you. Okay, so again, I'm going to draw like the simplest angle in quadrant 3, which would be a positive angle, just, you know, the least amount of revolution possible. So this angle theta goes like that. It should be between 0 and 360. Of course, I could have spirals, you know, go negative. Then I need to find a coterminal angle to do all my work. But I'm going to use my green marker again, and I'm going to trace, like, what is my reference angle in this particular quadrant? Okay, well, the reference angle is formed by the terminal side. So I'm going to trace the terminal side and the horizontal x-axis. But remember, you got to go back to the part that makes it small, acute. So am I going towards the positive x-axis or the negative x-axis? Negative again, right? You'd want to go back to the left again. That way, this angle that you form right here, theta prime, that's going to be small. It's going to be acute. If you went back to the, like, 360 degrees, then you're going to be over 90, and that's not acute. Okay, so now we got to think about, well, what if it's an angle in quadrant 3? How are we going to find the value of theta prime? So again, for me, as I'm trying to formulate these rules for finding my reference angle, the easiest way is just pick a number. So like, what's an angle that could be in quadrant 3 in degrees? 240. Okay. If we knew that this regular angle was 240 degrees all the way there, how would we find this little piece right here? 270 minus 240 would give me this little angle. 240 minus 180. Because like, think about this. Quadrant 1 is worth 90. Quadrant 2 is worth 90. So by the time we get to this negative x-axis, we know 180 degrees of the angle. And if you're saying that you still got to keep going to 240, how much overflow did you have? So we would write that out as theta prime equals theta minus 180. So, like, look, quadrant 2 and quadrant 3, they're both going back to negative x-axis. That's always 180 degrees. They're both related to that 180. You don't want to use 270 because you're never going back to the vertical axis. You should always be going back, remember in the definition, to the horizontal axis. Okay? And then, you know, using Jet's tip from quadrant 2, we know that's in radians just going to be theta minus pi. So, what did you give me, 240? Okay, 240 in radians is 4 pi over 3. Well, 4 pi over 3 minus pi, that's like 4/3 minus 1. 4/3 minus 3/3. 1/3 pi again. So, that's small and that's acute and that works. Okay, we got one more to go. Quadrant 4. You know the drill, how to draw the picture, right? What about quadrant 1? It's already acute. Now I did mention, and I'm going to say this again here at the end, Mason. I did mention, you could have angles in quadrant 1 like 380. That's in quadrant 1 because you got to go all the way around, then you got to go a little bit more. To actually find its reference angle, you need the coterminal angle of 380. 380 minus 360 is 20, but then there's your reference angle. It's 20 degrees. Okay, so this time I'm going to do theta like this. And I'm going to trace where my reference angle would be using the definition of a reference angle, terminal to horizontal axis. So terminal side is where it lands. Where would I be going back to now? The right side, the positive side of the horizontal axis, right? So this little section, that's my theta prime. I'm going to label this Q4. Can someone think of an angle in degrees that would be in quadrant 4? 320. So let's say the red angle was 320 degrees. How would you figure out the green angle? 360 minus 320. Isn't it like the red angle plus the green angle makes a whole circle? So you just have to subtract it from the full rotation. 360 minus 320, but we're going to put theta there. And then if we had an angle in radians, which 320 I don't know off the top of my head in radians, but well, let me see, 32 over 18 divided by 2 would be 16 over 9, 16 pi over 9. 16 pi over 9. So instead of subtracting that from 360, we'd be subtracting it from 2 pi. So 2 pi minus theta. And if we changed 320 to 16 pi over 9. If I subtracted that from 2 theta, since it's 16 pi over 9, 2 pi, if it were to have a denominator of 9, just double that, it's 18 pi over 9. Okay, and then 18 pi over 9 minus 16 pi over 9. 2 pi over 9 is my reference angle. When I change that back into degrees, that's 40 degrees, so yeah, it's so cute. But see how I can work in radians? I'm not scared of a radian. You shouldn't be either. Okay, now, these rules, like I said, you're going to need to know these rules for quizzes and tests. That's why homework, your daily practice, is so important. I don't really expect you to sit down and study and memorize. Only I expect you to do the practice, and then as you're practicing, you get more comfortable and you know what the numbers are. But those people who don't practice, I'm going to get people who subtract from 270 and 90 for sure. Okay, so you got to do your homework, you got to do your practice. The other thing that I have to say about these rules is this only works if theta is less than 360 degrees but greater than 0. Or less than 2 pi but greater than 0 radians. It only works in those cases. So that goes back to that example I was telling Mason about when he asked again about quadrant 1. You know, if I pick something in quadrant 2, okay, 500 degrees. If we graph 500 degrees, it will land in quadrant 2. But certainly 180 minus 500 it's not going to give me a positive acute angle. So I need to find a coterminal angle first, like 500 minus 360. 500 minus 360 is what, 140? And then I can do 180 minus 140, and that's 40 degrees, which is a positive and an acute reference angle. Okay. So find coterminal, if not, in that range. And it also would work for like a negative angle, like negative 120. Negative 120 is in quadrant 3. If I did my rule for quadrant 3, negative 120 minus 180, that's not going to be positive in an acute angle. So you just have to be thoughtful about this rule that has to be within one positive revolution of the circle first. Okay, so let's do some examples. We're going to sketch the angle. That's helpful because like once you decide which quadrant it is, you can think about those rules just the same way we did. They make a whole circle, so I'll subtract from 360. They make 180 degrees, so I'll subtract from 180. Or it's over 180 degrees, so I'll subtract that from my angle. Once you decide the quadrant, it's easy to tell the rule. And then you're going to find the theta prime. Okay, so let's start 260 degrees. Everybody graph 260. When you graph an angle, you should show me the initial side on the positive x-axis. 260 is going to land its terminal side in which quadrant? 3. Quadrant 3. It's really close to 270, which is that negative y-axis. So there's theta. Now, I then, if I can imagine in which quadrant it is, I think about my reference angle. Terminal side, negative x-axis, so that it's acute, right? So there's my theta prime. Okay, what are we going to do with 260 to get theta prime? Subtract it from 180. 180 minus 260. Subtract 180 from 260. Okay. 260 minus 180. It's that overflow idea, right? We know quadrant 1 and quadrant 2 together make 180 degrees. We just want to know what the overflow of those two quadrants is. So subtract 180, and we get, what is that, 80? Is that positive? Is that acute? Cool. Okay, see what you can do for me with 7 pi over 5. In radians, don't change it to degrees. Give yourself a moment to think about it. You'd be happier in Algebra 3 and pre-calculus if you at least try radians in Honors Algebra 2. My saddest students are the students that always convert. Where is 7 pi over 5 going to show up? This whole like bow tie and butterfly thing, like I just want to really drive home this idea that you're going back to horizontal axis. So I'm not ever going to say that. Okay, in radians, we start at 0, and we know real easy halfway across is pi. all the way across is 2 pi. So that's 1 and 2. 7/5 is more than 1. Because this is then like 5/5. And what would 2 pi be? 10 pi over 5. Okay. So we know it's somewhere in quadrant 3 or quadrant 4. To decide its location, what's exactly in between the numerators, 5 and 10? 7.5 pi over 5. So where will 7 pi fifths be? Quadrant 3. Similar story, right? It's almost that quadrantal angle. So it's somewhere in quadrant 3 again. I guess I didn't realize I made 2 in quadrant 3 or quadrant. And find your reference angle. So that's this angle again. So we're going to take our angle, 7 pi fifths, and we're going to subtract all this stuff that we don't want up here, which is how much? Yeah, 5 pi over 5, or just pi, right? I mean, you could use common denominators if you wanted to. I will say this. Like, 7/5 pi minus 1 pi should be pretty easy for you to do. 7/5 minus 1. How many over 1 do you have? 2. It's 2 pi over 5. Is that positive? Yes. If you're questioning if that's acute in radians, remember that first quadrant is from 0 to pi halves. Is this less than 1/2? 2/5? Yeah, because 1/2 would be 2.5 over 5. So yeah, it's acute. All right, let's do 2 more. What if theta's not in the space we needed? I didn't even talk about that, right? Let's do theta equals negative 740. Well, it's negative, so now it's going clockwise. And if I think about going clockwise in degrees, 1 full revolution is negative 360. And you might be familiar with 2 full revolutions is negative 720. So to be negative 740, I'm just going a little bit past that, right? So we could be pretty sure it's in quadrant 4. So I'm going to draw my initial side. I'm going to go clockwise. 1 revolution, negative 360. 2 revolution, negative 720. And then I need to get to negative 740, so that's only a little bit more. Okay, we're focused on now finding our reference angle. So that's our terminal side with the positive x-axis. So we want this small angle right there. Now, normally in quadrant 4, we would just take 360 minus the angle, right? But 360 minus negative 740 is not going to be acute. So in the case like this, add 360, and that's only going to get me still to a negative, right? Because it's adding 720. Add 360 again. That's 340. So this is coterminal angle. Now I can do reference angle. Theta prime is 360 minus 340. Just 20 degrees. Now, some of us may have been guessing that it was 20 degrees before we did all that work, right? Because when I described like how I gotta go around once and then I gotta go around twice and we're at negative 720, and we need to get to negative 740, which is just really 20 more negatives, right? So what's that angle measure going back? 20 degrees. But I'm going to show you the full work so that if you're ever stumped, you don't have to guess. You know how to do it. We'll do one in radians. 13 pi fourths. Okay, think about where you would plot 13 pi fourths. You probably want to be labeling some things on your coordinate plane so you can get in the right spot. Try to avoid that conversion to degrees. You want to learn radians, so you've got to use radians. This one's positive, so I'm going normal counterclockwise. I'll just go ahead and label my pi my 2 pi. With a denominator of 4, this would be like 4 over 4. And what would 2 pi be? 8 pi over 4. Now, that means that this is more than one rotation, right? Okay. So what I would probably do after that, 8 pi over 4, this is 2 pi, right? What if after I'm already at 2 pi, I go halfway around? Then I'm at 3 pi. And 3 pi with a denominator of 4, just multiply 4 by 3. What would the numerator be? 12 pi over 4. So now we're pretty close to that, right? 13 pi over 4. Because I'm at 12 pi over 4 or 3 pi, remember that in radians, each quadrant is pi over 2. But to get to 13 pi fourths, I only need one more 1/4 pi. So it's got to be in quadrant 3. So I can go ahead and draw my angle in quadrant 3. I would go around one whole time and then a little bit more. And I gotta find my reference angle, terminal side to the negative x-axis so that it's acute. Normally we would do like, in that one we've already done it a couple of times, so we would do the angle minus pi, right? But we don't want to start with 13 pi fourths minus pi. That'll get me to what? 13 minus 4 is 9. 9 pi fourths, that's not acute in any way. So we need to do that coterminal work again. We already know what 2 pi is, right? 8 pi fourths. So 13 pi fourths minus 8 pi fourths is 5 pi fourths. That's between 0 and 2 pi. So now I can do 5 pi fourths minus pi. What's left over? 5 fourths minus 1. 1/4 pi. Because 1 is 4 fourths. And pi over 4 we know is in quadrant 1. So yeah, that is acute. And it's positive. Okay. So you're going to have some time on your homework to practice things like that. You know, I'll be real honest. This can be like a weird time for a lot of people, like the reference angle. So I really want you to practice. I really want you to think about that definition of the reference angle. And really go for it with this whole sketching the angle thing. the sooner you kind of like sit and think about these angles, the much happier student you're going to be. If you always sort of throw your hands up and just wait for me to graph it, you're never going to get better at graphing that angle. So you got to really put in that work and label those sides and stuff like that. And certainly come in and see me if you have any questions about it. These are some tips to finding reference angles. So if you want to jot any of them down, you can. I'm also, if you're writing, I'm going to come around and give you a circle that has our special angles on it. And you can take them into your notebooks. Just be real tape efficient today. You probably only need 2 small pieces, one for the top, one for the bottom. You need not tape on all sides of the little square. It'll stick in your notebook if you need it. I will post these notes online today, so if you're not writing down these steps but you need some help on your homework, I'd come back and look at this slide. It tells you what to do, step by step. Kaylee, you want to grab the tape dispensers? You can give one to your pot and give one to Taylin's pot right here. Okay, so that number 1 up here, remember it's got to be between 0 and 360 or 0 and 2 pi. So that whole add or subtract 360, add or subtract 2 pi until it is. So find the coterminal if it's not. Sketch the angle to decide the quadrant, because once you decide the quadrant, you could just decide, should I subtract from 180 or should I take 180 away from that angle? Or in quadrant 4, should I subtract from 360? Okay, and if you land in quadrant 1, then you'll know you're done. Finally, then calculate the reference angle. Notice that your reference angle should always be drawn back to the horizontal axis, so it's part of that bow tie, right? And you want to go back to the part that makes it acute. So you always get these triangles like we saw in our notes on Tuesday. And then finally, double check to make sure that theta prime is positive and acute. Okay, so you know something's wrong if theta prime is negative. You know something's wrong if theta prime is obtuse. Okay, so try to figure out where you're going wrong. What mistake have you made?
Oh, thank you.
Okay. Now you got this taped in your notes. Take a color highlighter. It doesn't matter which color you choose right now because you're going to go through 3 of them. Take a colored highlighter. I see some highlighters just sitting there. Take a colored highlighter. And I'm going to show you, why is 120, 135, 150, 210, etc., why are these the special angles in the other 3 quadrants? Why do I want you to know those angles? Okay. Take your highlighter. Start at the origin. Go out to 30. Drop it to make a right angle. And draw your triangle. Okay, that angle right here at the origin, that's 30 degrees, right? You don't have to write that in. Okay, the highlighter, that'd be kind of messy, but that's 30 degrees. Okay. Now, take that same color highlighter, start at the origin, go back to 150, bring it down, draw the triangle. You see how those triangles look almost exactly alike? Similar? Congruent? Okay. If we calculate the reference angle for 150 in quadrant 2, we would do 180 minus 150, which is 30. So this is also a 30-degree angle. Which angle do you suppose is going to match in quadrant 3? Which one should you draw to with the same color? 210. And in quadrant 4? 330. It's a bow tie. Oh my gosh.
Was
So those are called the special angles because 150, 210, and 330 are the 30-degree reference angles in quadrants 2, 3, and 4. Now trade colors, and you're going to do all the 45 degrees.
yes.
So go 45, 135, what's that? 225, and 315. It's another bow tie. Those angles, 135, 225, 315, those are the special angles because their reference angles are always 45 degrees. And that's a special angle. And they can trade colors. And do your last one. $60, $120, $240, $300. Notice that as you draw in that same color for the reference angles, those triangles are all like oriented the same way. If you just like reflect over horizontal and vertical axis, it just is the same triangle over and over again. So they all look like the same triangle. They're all 60-degree reference angles. That's going to be really important leading into tomorrow. I'll have you guys just leave the highlighters out at the pods. Before you pack up, I know everybody's like looking at that clock. I see you. Okay, let's name the angles in radians in quadrant 1. Does anybody remember what 30 degrees is in radians? No. Pi over 6. I always remember those like they're mismatched. 30 isn't pi over 3, it's pi over 6. Because if you cut something into 6 pieces, it's smaller than when you cut it into 3. Like 30 is smaller than 60. Okay, what's 45?
Pi over 5.
Nope.
Pi over 9.
Someone with an answer. Pi over what? 4, thank you. And 60.
Pi over 2.
We already know 90 is pi over 2. We should be really clear on that. Otherwise, we need to spend more time doing our homework and studying. Okay, so let me help you out with the special angles in these other quadrants. Remember all the reference angles in quadrant 2 are pi minus the angle? Well, for this red one, that's pi over 6. What's 1 pi minus pi over 6? 1 minus 1/6. 5/6. On the blue, what's 1 minus 1/4? 3/4. What's on the green? 1 minus 1/3. 2 pi over 3. See, look at all of these numerators and denominators. They're always one less in the numerator because they're missing the pi sixths, the pi fourths, and the pi thirds. They don't have a whole one. In the third quadrant, you have to add them to pi. So then this one's going to be 7 pi sixths, 5 pi fourths, and what about 240? 4 pi over 3, because it's part of the pi over 3 family. It's green in my picture. All the ones, now look at your butterfly. All the ones that are green, or like whatever are 60, whatever color you have, pi over 3, 2 pi over 3, 4 pi over 3. This one's going to be something over 3 in radians, because they're part of that pi over 3 family for reference angles. To do the last quadrant, remember that theta prime is 2 pi minus that. So, like if we're doing the pi 6, 2 pi would be 12 pi 6. Minus 1 would be 11 pi 6. Double the denominator and subtract 1. For the pi fourths, that'd be 8 pi fourths minus 1, which is 7 pi fourths. And for the pi thirds, double it, that'd be 6. Take one little piece away, 1/3. So we're at 5 pi thirds. So that's an easy way, like, you should know those angles and not always have to convert them times 180 over pi, etc. If you know how they're related like that, that makes it a lot easier to be like, oh yeah, that's a special angle. The work today, bring that stuff tomorrow because we're going to use it to do trig functions of any angle that's a special angle on that unit circle.